Hi guys, hello everyone, this is Saurav here and welcome to today's session on the Vedantu VOS channel. I apologize, I was not around to record a session last week. So today we'll be discussing a very interesting topic which I wanted to discuss last week, which is known as the hydrolysis of esters. ये hydrolysis of esters आप अपने school में, institute में, you might have read about hydrolysis of esters in a very simplistic way. But we will be investigating hydrolysis of esters in a more detailed way. The reason why hydrolysis of esters becomes a more challenging part and why we are gonna discuss this to a greater extent, इस पे एक वीडियो बनाने की क्यों जरूरत पड़ी? Because hydrolysis of ester is not that very straightforward when it comes to different types of esters. You have to understand that the mechanism is very plural. प्लूरल का मतलब इस मैकेनिज्म को होने के बहुत सारे तरीके हैं. देयर आर मोर देन वन वेज फॉर दिस मैकेनिज्म टू ऑकर. एंड व्हाई डू वी हैव सच व्हाई डू वी हैव सो मेनी डिफरेंट वेज ऑफ occurrence of this mechanism? First and foremost, let's try and understand that what is an hydrolysis of an ester. तो अब hydrolysis of ester आप जानते हो, बहुत सिंपल सा एक रिएक्शन है. आपने एक एस्टर लिया RCOR- and you have hydrolyzed this, added it to water. Eventually ये रिएक्शन एक एसिडिक मीडियम में होता है या फिर बेस कैटलाइज्ड मीडियम में हो रहा है. You will get a certain product, and usually the product is either a carboxylic acid or carboxylate plus R-OH. You will always get this as the outcome in a hydrolysis of an ester reaction. तो अगर इतना ही सिर्फ था तो why did we had to make a video on this? So let's try and understand कि hydrolysis of ester में issue कहाँ पे आता है, और या फिर what is that which is not taught in regular course of a study. So hydrolysis of ester is a very plural mechanism because it can proceed through several distinct methods. There are several distinct mechanisms through which hydrolysis can take place. Why do we have these distinct mechanisms? इसके तीन reasons हैं. सबसे पहला reason ये है कि there are two ways in which bond can break. Okay. So there are three reasons. First reason is there are two ways in which bond can break. अगर आपने एक एस्टर लिया, so RC double bond O R-. So आप ऐसा समझने की कोशिश करो कि हाइड्रोलिसिस जब होता है then I can split this bond or I can split this bond. इसको बोलते हैं एसाइल ऑक्सीजन लाइसिस. And this is called alkyl oxygen lysis. या फिर आप इसको बोल सकते हो एसाइल ऑक्सीजन बॉन्ड which has been broken. Why it is acyl? Because ये group acyl है, this is acyl, and so this is known as acyl. The first one is known as the acyl oxygen lysis, and this bond if is broken, though alkyl group and oxygen bond is broken, so therefore it is known as the alkyl oxygen bond lysis. तो दो तरीके हैं बॉन्ड को ब्रेक करने के. Another reason that there are some distinct mechanisms, is more than one mechanism for this reaction to occur, is that this hydrolysis can take place through an acid catalyzed mechanism or through a base catalyzed mechanism. मतलब इसको करने के या तो आपने acid को you have catalyzed the solution or the reaction with an acid, or you have catalyzed it using a base. And third reason is that the reaction can go by either unimolecular pathway or by a bimolecular pathway. मतलब कि या तो फर्स्ट ऑर्डर हो सकता है या फिर सेकेंड ऑर्डर हो सकता है. Okay, either first order or second order, and because of which हमारे पास एक से ज्यादा मैकेनिज्म आ जाते हैं. एक आउटलाइन अगर हम देखें एसाइल ऑक्सीजन लाइसिस का, so this is what acyl oxygen lysis looks like. You have an ester and a acyl. This carbon is known as the acyl carbon, and this acyl carbon and oxygen bond is broken, and you get a acid and a alcohol. This is one methodology, or this is one pathway through which an ester can convert to acid and alcohol by hydrolysis. Another method is that an alkyl group and oxygen bond can break. So this is the alkyl carbon. Therefore, you have two distinct lysis processes. One is acyl oxygen, one is alkyl oxygen. ठीक है. चलो देखते हैं कि कितने मैकेनिज्म्स पॉसिबल हैं और कौन कौन से मैकेनिज्म नहीं हो सकते हैं, या फिर इज देयर ओनली वन और इज देयर मोर देन वन. पहले तो हमने आइडेंटिफाई कर लिया कि मोर देन वन तो होना ही चाहिए, लेकिन मोर देन वन में कितने मोर देन वन. सो हमें ये जानना होगा कि इन मैकेनिज्म्स को जब हम लेबल करते हैं, दीज मैकेनिज्म्स आर लेबल्ड एज इन अ सर्टेन शॉर्टहैंड. Okay, so mechanistic courses are designated by some shorthand notations in which A and B refer to acidic and basic medium. And there are certain subscripts that we use, AC, AL, and numbers 1 and 2. So let's try and understand. मान लेते हैं कि अगर एक एस्टर है जिसमें ये बॉन्ड को हम ब्रेक कर रहे हैं, so can I say that in this case we are performing a acyl oxygen lysis? If we are performing an acyl oxygen bond lysis, then इसका notation हो जाएगा AC. Now, this acyl oxygen lysis can take place in acidic medium or basic medium. So, अगर ये एसिडिक मीडियम में होता है या एसिड कैटलाइज्ड हो गया, then I will write it as A subscript AC. The normal A is a representation of the catalyzed medium. Okay? या अगर वो nature of medium को represent कर रहा है, if it is acidic then I will write A, if it is basic then I will write B. So if it is base catalyzed, just a moment. So if it is base catalyzed, then I will represent it as BAC. Okay, is that clear? Depending on what kind of a medium have I chosen, on the basis of that I will classify the mechanism into two parts. One is BAC and one is AAC. अब ये पॉसिबल है कि जो मैकेनिज्म एसिड कैटलाइज में चल रहा है वो फर्स्ट ऑर्डर मैकेनिज्म से प्रोसीड करे और इट प्रोसीड्स बाय फर्स्ट ऑर्डर पाथवे. इट इज आल्सो पॉसिबल दैट इट प्रोसीड्स बाय अ सेकंड ऑर्डर पाथवे. तो आई कैन हैव दिस इफ इट प्रोसीड्स बाय फर्स्ट ऑर्डर, प्रोसीड्स बाय सेकंड ऑर्डर. So if it proceeds by first order, then I will name it as AC1. Second order, AAC2। ये हो गया हमारा नोटेशन लिखने का तरीका। So if I let me just erase this part and write everything over here. So we have how many possible outcomes if I take only acid catalyzed, then acid catalyzed will be either AC or AL. Base catalyzed, I will have AC or AL. So I will get two outcomes, AC, AL. Feasibility बाद में देखेंगे, but this will be BAC and BAL. BAC means base catalyzed acyl oxygen lysis, and BAL means base catalyzed alkyl oxygen bond lysis. Now ये हो जाएगा first as well as second, so ये AAC1 and AAC2, this will be AAL1, this will be AAL2. The same two such pathways can be written for each of them, so we have a total of 8 mechanisms. Okay, जो आपने पढ़ा होगा स्कूल में या फिर in your institutes, you might have read about only one of these mechanisms or maybe at the max 2 of these mechanisms, but we have a total of 8 mechanisms. So if I try to identify, देखिए BAC1, BAC2, BAL1, BAL2, AAC1, AAC2, AAL1, AAL2. We have a total of 8 mechanisms. However, इसमें से कुछ mechanisms नहीं होते हैं, जैसे कि BAC1 नहीं होता है. Okay, BAC1 doesn't occur. Okay, and AAL2 doesn't occur. Out of which, out of these 8, these two do not occur, but it's not that all of the others will occur with equal propensity. All of them occur with equal feasibility. ये भी नहीं है. कुछ एक काफी कॉमन है, जैसे BAC2 सबको पढ़ाया जाता है. BAC2 is very common and AAC2 is also very common. Okay, ये दोनों को हमें पढ़ाया जाता है. अब हमें we have to identify कि कौन से हो रहे हैं and why something is not occurring. Okay, so let's start. Let's start from the BAC2 mechanism, जो कि सबसे कॉमन मैकेनिज्म है. BAC2 mechanism को हम आइडेंटिफाई किस तरह से करते हैं? What is a BAC2 mechanism? It's a base promoted acyl oxygen lysis or acyl oxygen cleavage bimolecular mechanism. Okay, so base promoted acyl oxygen lysis bimolecular mechanism. ठीक है, ये कहां ऑब्जर्व होता है? So this reaction proceeds by an acyl oxygen cleavage and involves an addition elimination sequence in which displacement of RO minus by nucleophile OH minus takes place by a formation of a tetrahedral intermediate. And it's a highly exothermic last step which makes the reaction go in the forward direction. इस reaction को आप saponification भी बोलते हो. ठीक है, इसको हम saponification भी बोलते हैं. So let's look at how the mechanism appears like. So you have R, C double bond O, O R dash. This comes in contact with OH minus. OH minus attacks over here. It creates R, C, O minus, OH, OR dash. It comes over here. This goes out. आपको ये जानना होगा कि दिस इज द इंटरमीडिएट, दिस इज द टेट्राहेड्रल इंटरमीडिएट दैट वी आर टॉकिंग अबाउट, tetrahedral intermediate. So RCOH plus R dash O minus, but this is a very strong base. This is a strong base. This one is a very strong base. So it will react with the acid to generate a carboxylic acid salt. And ये जो last step of the reaction है, जो आपने देखा, जो last step of the reaction आपने देखा, this last step of the reaction is in fact the most exothermic step. ये सारे जो steps हैं वो reversible हैं. The first step is reversible. This one is also reversible, but this one is irreversible. And this is an acid-base reaction. And therefore this is exothermic as well. It is so exothermic that it will drag the reaction in the forward direction. ठीक है, इसी को हम सपोनिफिकेशन बोलते हैं और सोप फॉर्मेशन मेथड. इसका एक सिंपल सा एग्जांपल मैं ले लेता हूं. सपोज आई टेक इथाइल C double bond O methyl. Let's say this oxygen is labeled O18 and इसको आपने ट्रीट किया NaOH के साथ aqueous medium में. What would happen is Et C double bond O minus will be created and MEOH will be created. और ये जो ऑक्सीजन है, this oxygen will stay with Me because lysis कहां पे हो रहा है? इस बॉन्ड का lysis कर रहे हो आप. Okay, this stays with methyl. Okay, so this is a saponification reaction. This is a BAC2 mechanism. ये second order mechanism है क्योंकि जो RDS होता है इस reaction का, the RDS of this reaction is the attack of, ये आप देख लो, ये होता है RDS. ये RDS होने के कारण यहां पे आपने कितने स्पीशीज यूज किए हैं? You have utilized 2 species. One is this and the other one is this. So if this is an elementary reaction and 2 entities are involved, then the molecularity will be 2 or it will be a bimolecular reaction. Also the order will be 2. ठीक है? So ये हो गया BAC2 mechanism. हम बेस कैटालाइज जितने मैकेनिज्म उसको हम पहले खत्म कर लेते हैं and then we'll move on to acid catalyzed. We will also look at why a certain mechanism does not take place. Let's move on to BAL1. Okay, मैंने आपको ये बताया कि BAC2 होता है but BAC1 नहीं होता है. Okay, why BAC1 does not take place? BAC1 होने के लिए, for BAC1 to occur, BAC1 इसको होने के लिए, can I say rate determining step में I should be having only ester and in the slow step of reaction first order है तो मतलब सिर्फ एक ही कंपोनेंट रहेगा. In the slow step of reaction the acyl oxygen bond lysis should occur. So slow step reaction में I should be getting this. ये आराम से टूट जाना चाहिए. R dash O minus. This should happen. Should happen. But this compound जो ester होता है, it is never that polar that it will split like this. This is not at all so very polar that a acylium ion will be generated. Not quite polar to split to give RCO plus and RO minus. Therefore, a BAC2 does not occur. Sorry, BAC1 does not occur. Okay? Let's move ahead to BAL1 mechanism. AL का मतलब alkyl oxygen bond lysis और base catalyze mechanism ये होगा. हमें ये समझना है कि ये कहां पे हो सकता है और under which condition we will be able to observe this. Okay, so it is a base promoted acyl oxygen cleavage and unimolecular reaction. Base promoted acyl oxygen lysis unimolecular mechanism. ये कब होगा और under which condition we will observe this? Let's see. So esters undergo hydrolysis by this mechanism when alkyl group, sorry, alkyl, you know, this is not acyl, this is alkyl. Alkyl group attached to acyl oxygen. Alkyl group attached to acyl oxygen can form a relatively stable carbocation and the solvent possesses high ionizing power. मतलब आपके पास ये एस्टर है, ठीक है, आपको ब्रेक क्या करना है? एल्काइल एंड एल्काइल कार्बन एंड ऑक्सीजन के बीच का बॉन्ड. सो यू वांट टू ब्रेक दिस. ये तब ब्रेक होगा और अंडर विच कंडीशन इट विल ब्रेक? इफ this carbocation is stable. Okay, this carbocation is stable and ये कार्बोकैटायन स्टेबल रहेगा तभी जाके ये प्रोसेस हो सकता है. एंड फॉर दिस वी रिक्वायर अ वीकली एल्कलाइन मीडियम. Why do we require a weakly alkaline medium? Because we want to stop SN2 reaction. मतलब हम ये नहीं चाहते हैं कि इस R plus के ऊपर ये एसिटेट जो निकल रहा है that attacks. Okay? Is that clear? So how do we look? What is the mechanism of this? The mechanism, I will give you a mechanism. I will give you a compound which can show this. So RCO R dash एक slow step में this will come over here and I would be getting RC double bond O minus plus R plus. This R plus reacts with H2O in a fast process to form ROH, and this species converts to RC double bond OH ER dash. So आपको ये समझना है कि ऐसा कौन सा कंपाउंड होगा which will give rise to this. एक बहुत सिंपल सा आइडिया है कि हम ऐसा कोई एस्टर ले लें जिसमें the R dash is capable of forming a very stable carbocation. ठीक है, एक ऐसा कंपाउंड ले लें in which the R dash is capable of forming a stable carbocation. For example, could something like this. So something like this. If I look at this part, ये part को अगर मैंने observe किया, I will find that this carbon which is attached to oxygen looks like a benzylic carbon. और अगर मैंने इसको Na2CO3 के प्रिंसिपल aqueous OH minus के प्रिंस में रिएक्शन करा दिया, then I will be getting this species plus pH COH MEH, एंड ये जो चीज रहेगी ये एक कार्बोकैटायन बन के बाहर निकलेगी. Okay, it will form a carbocation, it will come out. Perfect. So you have to remember कि BAL1 mechanism का मतलब ये कि आपका कार्बोकैटायन बनना चाहिए पहले स्टेप में, and carbocation will be formed by the alkyl group which is connected to oxygen. It should not be just about any alkyl group. It should be an alkyl group which is capable of forming a stable carbocation. So this becomes a BAL1 mechanism. Let's look at what is a BAL2 mechanism. BAL2 mechanism क्या होगा? BAL2 mechanism ऐसा होगा कि जिसमें जो it's a base promoted alkyl oxygen lysis bimolecular reaction. First and foremost, base promoted alkyl oxygen lysis bimolecular mechanism. ये कहां पे होगा? So this mechanism similar to SN2 in aliphatic saturated compounds like alkyl. So just similar to SN2. ये सेकेंड ऑर्डर है. इसका मतलब यू हैव दिस RCO R डैश एंड बेस कैटलाइज, तो मतलब कि OH माइनस यहीं पे अटैक कर रहा है, ये यहां पे अटैक कर रहा है, एंड दिस इज ओपनिंग अप. सो दिस इज द फर्स्ट स्टेप, दिस इज द सेकंड स्टेप. यही आपका स्लो स्टेप ऑफ द रिएक्शन है, एंड यू आर गेटिंग RC डबल बॉन्ड O माइनस प्लस R डैश OH. ये मैकेनिज्म होना चाहिए आपका. ठीक है, ये तब होगा. ओके, this happens when nucleophilic attack on the ester of the carbonyl group is inhibited due to steric crowding by the alkyl groups. मान लीजिए कि ये जो ग्रुप है, this group is very bulky. Okay, this group is very bulky. Then rather than OH, देखो इसका मैं आपको दूसरा दिखा देता हूं, AC2 मैकेनिज्म, यहां पे OH माइनस अटैक कर रहा था. If this one is very bulky, then it will go by BAL2. Okay, so AC2 will happen when the alkyl group connected to acyl carbon is ठीक ठाक छोटा मोटा है. Okay, it's not very bulky, but if it is very bulky, then OH minus has to attack somewhere. It will attack the alkyl group and perform a displacement of the acetate unit or the carboxylate unit. Okay, so this is how the reaction will take place. Let's look at an example. So मान लीजिए कि एक काफी sterically hindered alkyl group मैं ले लेता हूं, which is connected to C. And over here we have CH3. Let's try and understand. If you present OH minus in front of it, OH minus cannot attack over here. This attack is not favored due to steric hindrance. So अब होगा क्या? It would rather attack over here and this way. So 1, 2. and it will proceed by a slow step to create this. Understood? कब होना है ये? जब alkyl group connected to acyl is bulky. If alkyl group connected to acyl is teeny tiny, small, छोटा मोटा group है, then BAC2 हो जाएगा. अभी जो हो रहा है वो BAL2 हो रहा है क्योंकि आपने इस बॉन्ड को ब्रेक किया है. ओके, नेक्स्ट AAC1. AAC1 is a very common mechanism. बहुत सिंपल सा मैकेनिज्म है. AAC1 कहां पे होता है? AAC1 का मतलब क्या हुआ कि आपने एसाइल कार्बन और ऑक्सीजन के बॉन्ड को ब्रेक किया है एन एसिड कैटलाइज मीडियम. सो इट इज एसिड प्रोमोटेड एसाइल oxygen lysis, and this is first order. Okay, it is first order. AAC1 will go like this. R C, let's say मैंने ये ले लिया R C R R dash, and this reacts with H plus. R C R R यहां पे आपने एक पॉजिटिव चार्ज लगाया and this breaks to form an acylium ion. ये टूट जाता है यहां से और इससे आपके पास एक एसाइलियम आयन जनरेट हो जाता है. ओके, आपने यहाँ पे ROH निकाल दिया, R-OH. This acylium ion undergoes reaction with H2O, losing H plus to form R3C C double bond O OH. Okay. ये कब होता है? when the nucleophile, that is water, cannot attack the acyl carbon due to steric hindrance. अगर H2O यहां पे अटैक करने की कैपेबिलिटी नहीं रखे तब जाके ये रिएक्शन होगा. So hydrolysis and esterification of esterically hindered esters because of steric crowding involved in transition state leads to this particular mechanism. This takes place only in powerful ionizing solvents क्योंकि आपने cation बनाना है. Cations will be created only when you have powerful ionizing solvents. Let's look at one mechanism. Okay, so something like this. Me, and there's Me, C double bond O, Me. This reacts with H plus and अपने पास कुछ ऐसा क्रिएट हो जाता है Me. This will split I'll get this, and then it will react with H2O and lose H plus to form this. Okay, so this is AAC1 mechanism. Next, AAC2. AAC2 most common mechanism of acid catalyzed. As AAC2 कब होगा? जब water will be able to attack the carbonyl unit of the ester. Okay, मतलब एसाइल कार्बन के ऊपर अटैक कर जाए. For example, R C double bond O O R dash. This takes up H plus क्योंकि acid catalyzed है. R C double bond O H with a positive charge. O R dash. H2O attacks here. This will be the slow step of reaction. I will be getting OH, OH2 plus, OR dash, and eventually this gets created, R dash OH. Okay, ये सबसे कॉमन मैकेनिज्म, ये सभी लोग पढ़ते हैं. इसमें there is nothing which is new over here. इसमें बस आपको ये चीज याद रखना होता है कि इसमें there is something known as microscopic reversibility which is observed. Microscopic reversibility का मतलब ये होता है कि the mechanism of ester hydrolysis exactly is the reverse of the mechanism of creation of an ester or ester formation, esterification reaction के एकदम उल्टा चलता है. That means acid catalyzed esterification is exactly the reverse of acid catalyzed hydrolysis of ester. Okay, acid catalyzed esterification is exactly reverse of the acid catalyzed hydrolysis of an ester. Conventional esters में अगर acid catalyzed mechanism कर रहे हैं ester hydrolysis के लिए, then we will be following AAC2 mechanism. The next one is AAL1. ये लास्ट मैकेनिज्म है इसका. AAL1 मैकेनिज्म का मतलब एसिड प्रोमोटेड एल्काइल ऑक्सीजन लाइसिस एंड यूनिमोलिकुलर. ये कहां पे होगा? अब ये समझने की कोशिश करो कि मुझे एल्काइल ऑक्सीजन बॉन्ड का लाइसिस कराना है एंड एसिड कैटलाइज्ड मीडियम में मुझे ये लाइसिस कराना है. आपको ये समझना होगा कि ये जो लाइसिस होगा, दिस लाइसिस विल टेक प्लेस ओनली इफ द एल्काइल ग्रुप. आप पहले याद करो BAL1 कब हो रहा था? BAL1 तभी होने के चांसेस थे जब कि वो कार्बन, वो this carbon which is connected to oxygen could have formed a stable carbocation. अगर वो stable carbocation बनाता है then वो reaction हो पाएगा. थोड़ा पीछे चलते हैं. BAL1. So BAL1 कब होने की possibility थी? जब this alkyl group can form a stable carbocation. Similarly, acid catalyzed medium में अगर एक stable carbocation बन गया तो again AAL1 mechanism follow किया जाएगा. Similar, just the difference is that we have a acid catalyzed condition. Previously we had a base catalyzed condition. So this mechanism esters in which the alkyl group R dash can form a stable carbocation. Benzyl 3-degree benzyl can undergo acid catalyzed hydrolysis mechanism. Again, microscopic reversibility is observed. So the mechanism is like this: RC double bond O O C R R R R1 R2 R3. ये H plus की प्रेजेंस में आते ही this R1 R2 R3 this turns into carboxylic acid and we get R1 C R2 R3 plus a carbocation, and then this carbocation will react with H2O, give out H plus, form R1 C R2 R3 ठीक है, एग्जाम्पल अगर मैंने लिया इस तरह का, so this compound will be capable of undergoing this reaction, AAL1. अब हमने इतने सारे मैकेनिज्म्स पढ़े हैं, इसमें हमने ये बोला कि BAC1 will not take place and AAL2 will not take place. AAL2 क्यों नहीं होगा? AAL2 होने का मतलब कि lysis takes place but it's through a second order kinetics. अब ये समझने की कोशिश करो कि this carbon will, आप किस तरह के कंपाउंड में ये ऑब्जर्व करोगे? लेट्स से एक मिथाइल ले लिया आपने और उसमें H2O अटैक कर रहा है यहां पे, तब प्रोबेबली हम बोलेंगे कि ये AAL2 मैकेनिज्म होगा, क्योंकि ये यहां पे अटैक कर रहा है, ये इस तरफ ये ब्रेक करेगा. लेकिन this carbon has less delta positive than this carbon and therefore H2O would preferentially attack over here. ये तो होगा ही नहीं कभी, ये हमेशा होगा, and therefore AAL2 is not observed. Okay, do you understand? If H2O attacks on the alkyl carbon, then alkyl carbon should be highly electron deficient, but there is a acyl group which is more electron deficient than the alkyl carbon under all conditions, and therefore H2O will prefer to attack at the acyl carbon rather than attack at the alkyl carbon in a second order mechanism. Second order का मतलब दो चीजें साथ में इंटरेक्ट कर रही हैं. H2O is not that great a nucleophile. Okay, so that's all for today, guys. I hope you enjoyed today's session. Please try to write one more example of each and every mechanism which is allowed for ester hydrolysis, and you can mail me at saurav.goswami@vedantu.com by writing the possible compounds which you think will undergo a certain mechanism, and I'll be happy to look at it. So that's all for today. We'll take up one such interesting topic in the next week, and until then, have a lovely time.